Here are the solutions to tracking test 5, the mechanics part. So we'll start with question 6. We've got a particle being projected vertically upwards. So initially it has some energy, which is kinetic energy. So that's a half m v squared. So that works out to be 100 joules. Finally, the final energy is potential energy, so that's mgh, so that's 0.5 times g times 10, plus the work done against the air resistance. So the work done is the force, r, multiplied by the distance, which is 10. So therefore 100 equals 0.5 g times 10 plus 10r. Put the joules in there, there we go. So 10r must equal 100 minus 0.5 times g times 10. So 100 minus 49 is 51, therefore r is 51 over 10, which is 5.1 newtons. For question 7, we've got a cyclist, there's a cyclist, cycling along a straight horizontal road with some sort of tractive force here, and there's a resistance. There's obviously the weight and a normal reaction. But we can consider what's happening horizontally by saying that the tractive force must equal the resistance, since there is no acceleration. Now we can use the fact that power is the force times the velocity, and we know that the power is 490 watts. We don't know what t is, but we know that the velocity is 3.5. So therefore t is 490 over 3.5, which works out to be 140, and since t equals r, we know that r must equal 140 newtons. In part B of question 7, the cyclist is now cycling down a straight road, and we know that the angle here is such that sine theta is 1 over 14. Now the key to this is to draw a good diagram. So we've got the weight, which is 70g, and we can resolve that weight into the slope and down the slope. Now the cyclist is cycling down the slope, so there's a tractive force. There's obviously going to be a normal reaction, and there's also going to be non-gravitational resistance to motion, and they've called that 40U. So now we've got this diagram, we can say that since there is no acceleration, 70g sine theta plus t must equal 40u. So since power equals force times velocity, we can say that the power which we've got is 24 watts equals t multiplied by u. In other words, t is 24 over u. So we've got two equations. If we put those together, we get 70g sine theta. Well, sine theta is 1/14th, and 70 is there, sine 1 over 14. So 70 divided by 14 is 5, so that becomes 5g. So that's 5g plus t is 40u. So now we've got a quadratic equation which we need to solve. Here it is, so let's multiply everything by u, and g is 9.8, so 5 times 9.8 is 49, so it's 49, 5g is 49, and we're timesing everything by u, so we get 40u squared there. So 40u squared minus 49u minus 24 equals 0. That factorises to be 5u and 8u, and then we need 3 times 8, it's minus and it's a plus, so therefore u equals 8/5, or u equals minus 3/8. Clearly u is not negative, so therefore u equals 8/5. U can't be negative because u is the speed down the slope, and so she's not cycling up, she's not cycling down the slope with a negative velocity. Now for question 8, we need to think about the shapes. We've got a rectangle, we've got a semicircle, and altogether it makes this shape here. It's not very good, but something like that. Then the mass is proportional to the area, so the area of the rectangle is 24x, the area of the semicircle is pi times r squared over 2, and since the radius is 3 squared is 9, half of that is 4.5 pi. So the total area is 24x plus 9 pi. The centre of mass, well, I'm going to take the origin to be O, which is not really a startling decision. Putting O in the diagram is a real clue that that's the best place to take the origin. So on my shape here, I'm going to take that as the origin, and I'm going to take that to be positive and that to be positive. So the centre of mass of the rectangle is going to be 0 along, and it's going to be minus x down. Centre of mass of the semicircle, well, they tell you that the centre of mass is at 4r over 3 pi, and seeing as r is 3, that's 12 over 3 pi, or 4 over pi. So it's minus some number, which I'm just going to call p, and this one's going to be p, not really bothered about that. And then, but the y coordinate is 4 over pi, that's 4 over pi. And the centre of mass here we're going to call x bar, y bar. Now clearly you can see that the centre of mass, the x coordinate of the centre of mass is going to be 0. It's going to be slap bang in the middle. It's going to be along this line here. They want the distance of it from SR, which is there, so we're just interested in the y component of the vector. So therefore 24x times minus x plus 4.5 pi times 4 over pi plus 4.5 pi times 4 over pi must equal 24x plus 9 pi times y bar. So how does this simplify? Well, 24x times minus x is minus 24x squared. Pi divided by pi is 1. 4 times 4.5 is 18, and we've got the same thing here, so altogether those two terms make 36. And y bar has been multiplied by 24x plus 9 pi. So this is now the distance up from the origin, because I took that to be positive. Maybe it wasn't a sensible decision. They want the distance from it downwards, so it's going to be just minus that lot. So therefore the distance from SR is 24x squared minus 36 over 24x plus 9 pi, just minus what we just had. So that's changed sign. In case you're not sure, I took the y direction to be upwards. As I say, maybe that wasn't the best decision, but that's what I did. We want the distance of the centre of mass from this line here that I'm drawing, so it's going to be downwards. So the distance is going to be in the opposite direction to this. That's why I've changed the signs.